Okay, sir. You can start, sir.
All right. So let's share the screen. I hope it's very clear and you guys understood what was covered so far. So we were able to control LED in the local Wi-Fi network, and pretty much the concepts behind it I have explained it in a simple way. Uh, when you start working practically on those things, it would help you to understand much better. So these are the steps, and all right. So to summarize, so the program behind controlling LED in the local Wi-Fi network, the steps are very simple. First step, create a server, and then create an access point, and then find the IP address, and then start the server, and then take actions based on the client request, and keep the connections alive. So this simple program, we're able to make you build a simple application where you are able to turn on the LED in a local Wi-Fi network using a browser wirelessly. So now, instead of opening up your browser and then zooming the window and then clicking the buttons, won't it be nice if you are able to build a Android application and just open up the app and then click the buttons on the app and then control? Yes, it would be more easier way of controlling, right? So the next concept that I'm going to teach you all is how you can build some simple Android application even without, if you're not having any programming language, it's fine. You can simply build some Android application using the MIT App Inventor platform. So that is what we are going to see next. So why MIT App Inventor platform is, it's a platform create Android application without programming knowledge. You can just drag and drop blocks, and then you can uh, create your Android application. So now, what else would you like to MIT App Inventor? And then this comes, open that MIT App Inventor link, and then all you have to do is create apps. So click on create apps. It's very simple and easy to use interface. Just look through the process that I'm doing, and you will be able to do it later as well. So I already have an account with MIT App Inventor. So if you're first time, all you have to do is create an account, like how you generally sign up with websites, right? All you have to do is that. So once you sign up your account, you will come to your dashboard. So your dashboard basically will be list of projects. So uh, how to create a new project is, so go to projects, start a new project, and give a name to it. Let's say CSC. Okay, let CSC be alone there. Once you create a new project, this window comes. So this is basically called the designer window. If you see here, uh, the designer window. So here on the top right, so it's designer window. It's basically the front end of the app. So whatever you want in the app to appear, right, you have to design in this window. And then the next important thing is the blocks window. So blocks is basically the logical functioning or logical programming of the app is supposed to be done there. So now in our case, you know what was the project that we were working in the morning? Like we created a web page with two buttons in it, and by pressing a button, you submitted a different value, and which in turn helped you to control the LED connected on the node MCU. So same thing here. So what you're going to do is you are going to what you're going to do is you're going to uh, add two buttons to the window. So button 1 and button 2. And how do you change the appearance? Name of the button is very simple. Select the corresponding element and you come here, you see a lot of options available. So you can even change the font, the size, everything, color, everything. So in our case, I'm going to keep it simple and change the name alone, LED on. So the first button is for LED on and the second button is for LED off, and you can change the colors, everything, if you are working for a project or something, or if you're guiding a student and so on. So now next important thing element that you need is connectivity, because in our case it has a local Wi-Fi connectivity, correct? So it needs a web connectivity. So from the connectivity tool, just drag and drop the web application, and it will not be visible on the screen because it's a non-visible component. So the front end is very much done. You have two simple buttons and you're going to program it in the blocks window now. How to make it work? So first thing, when the button 1 is clicked, what we did, so when button 1 is clicked, you called a certain web URL, that is the IP address of the node MCU, so followed by the LED web page and the state value getting changed. You notice all those things, right? You have to do that. So when button 1 is pressed, you have to call a web URL. So set web 1 URL to, okay, so here it is. So when it happens, you are going to call a specific web URL, and that URL you can type on your own. So just have a blank, and the URL you very well know, http://192.168.4.1/LED question mark state equal to 0 is the first one, right? And then when this is called, you have to get it. It's like pressing enter is like call web1.get, as simple as this. So this simple block will work like this. When you press the button 1, it sets the address of the address bar, address to that particular address mentioned in this text column, and then it calls that, right? Similarly for button 2, you can just do the same process if you wish, or duplicate it and then change the button number to 2, state value equal to 1 for the second button. That's it, as simple as this. So your app programming is over. So recapping the MIT App Inventor platform, it has two windows. One is the designer window. It's where the front end of the app is designed. And the second window is blocks, where you program the app using just blocks. That is drag and dropping blocks, you can do it. So now it is ready. So next step is again compiling this application and downloading it. You get two options. One is you can download the APK file to your computer. You can install it by copying it to the phone from your laptop and then doing it. And the first option is you can generate a QR code, and which you can download again. So I'm going for the QR code. So let it compile. So usually it takes some time.
So sorry to interrupt. One small doubt.
Yes.
After we click this button, how do we give this set and call, sir?
Which one?
And after we go to the blocks,
Okay.
we click the button 1. So a window like this, when and do, is getting opened. And how do we program this IP address?
This IP address is basically like I'll share you
Like
my phone. I'll share
I
you
was
my.
just doing it in parallel, so I was not able to observe it. That's why I'm asking it.
No problem. I'll show you why this particular IP address is there. While showing the demo, you will be able to understand. So now let
Okay.
me connect my phone.
Okay.
The address you will be able to see in the phone only. So can you see here the address bar of the phone?
Yes, sir.
192.168.4.1/LED underscore state equal to 0 for LED on. Correct. So same thing here. That IP address is repeated here. For LED on, it is state equal to 0, and for LED off, it is state equal to 1. And basically, call web1.get is to dial that IP address. It's basically you type something on the address bar of your browser, and then you press enter, right, to dial that address. So the same process happens here. Okay. So now let me download this particular app to my phone. And to download it, let me close here, go to the QR scanner. So, so I have, it's asking, do you want to download it? Yes, I want to download it. Open that, and it's asking, you want to install it? Yes, I do want to install it. And then once it's installed, let's open it. See the app that you built it's here. And now one thing that I have to change is I'm connected to the Wi-Fi at home. So now I have to plug in the Node MC that we're using in the morning. And then look for the network that this Node MC you created, Lema IoT. If it's not coming, just reset it once. You got like Lema IoT now. Connect to it and then come to your app. So now you see the LED turned on. So press LED off, it turns off. Got it? LED on the app, turns on the LED. LED off, turns off. So then opening up a browser, it's so easy, right? So having an Android application, open up the app, make sure you are connected to the network, and then you can turn on and turn off your LEDs, as simple as this. So that's MIT App Inventor for you. So off. So this is how you can build some Android application in MIT App Inventor platform. And now let me make it more interesting. So not just buttons, you can do a lot of cool stuffs using MIT App Inventor. So let's say I don't want to uh, use a button for on, right? So let's delete that. Now I have added one more thing. Did you see an accelerometer sensor I have added? It is also there in the non-visible component. Now I'm going to program like instead of pressing the button, I want it like whenever I shake my phone, I want my LED to be turned on. So that is what I'm going to do. Same process. So when accelerometer is shaking, same process. So all you have to do is go to web, set web1 URL, drag and drop it here. You have to put it in the right place. And then this one I want one more, so I'm duplicating it, and state is equal to 0, changed it. And this one I want one more, so duplicating it and putting it here. So now this simple program, you can understand the logic, right? When the accelerometer is shaken, it detects a shake, it submits this value to the web browser. So let's build this again and see if it's working fine. Similarly, you get all sensors available. You get all like you can build your own camera application. You can build your own SMS application. Everything using the MIT App Inventor platform. And it's not just for prototyping. Even in fact, you can develop apps and publish it to the Play Store. It is that powerful. So let me download this app again. I'm changing the network. So now let's go to the QR scanner. Scan, open. Meanwhile, let me connect to so that you can see. So here is the new app. Let's open, install it. Done. Open it. Now you see we have only LED off here, and here it is. So without fail, change the network. Lema IoT is here. Connected. It's getting connected. No internet, that's fine. Come to the app. The LED is already on. So to turn it off, press the button. And to turn on, just shake your phone. It will turn on the LED. So to turn it off, press LED off. By shaking your phone also, you can turn on things at your home. So as simple as this. So this is how MIT App Inventor can be played around, and as a student or as a faculty, you can work on a lot of cool and interesting projects using MIT App Inventor. To summarize, it's a very easy to use platform. It has two windows: designer window where you design the front end of the app, and the blocks window where you program the logic of the app. And what you get to work with is you have interface, basically the interface in the app. The layout also you can choose, vertical, horizontal, everything. Media is basically all the media facility available in your phone. And then you can also build games using the ball, canvas, everything. You can also work with map, sensors, all the sensors available in the phone. And then socially, like SMS, contact picker, phone call, everything is also possible. And you can also create a database in the app. And connectivity wise, it has Bluetooth and serial and web, everything available in the MIT App Inventor platform. So with this platform, you can build Android application at ease without programming language. And most of the IoT projects where you want to monitor sensor data or control something with buttons, sliders, everything using Bluetooth, Wi-Fi, everything can be done using MIT App Inventor platform. That's it. So any questions with respect to MIT App Inventor platform? Okay, so I think it's very clear and simple. So no doubts from you, chat. Is it paid? No, it's not paid. It's a open source and freeware. You can directly go and use that like link and create your account and then start building it. It's free. So MIT App Inventor is free platform to use, right? So now next step. So far what we have seen is we have been covering IoT over just local networking, that is without internet, in the local network, how you can control devices using simple Wi-Fi that was created by the Node MCU. So the next step where we are moving is we are moving towards the cloud side. So we are going to focus much on how do we send sensor data to cloud, and how do I get that sensor data and do something meaningful is what you are going to do, because IoT is all about monitoring and controlling. So this monitoring and controlling is only possible if you have a knowledge how to send something from your place to the cloud and get something from the cloud and do something meaningful in your place. So that is what we are going to learn now. So coming to cloud servers, we have like a lot of cloud servers available for us, starting from Google's Firebase, Adafruit, IBM Watson, Azure, and then AWS also has their own. And we use simple servers like Blink, ThinkSpeak, and then Cisco. Everyone is also there. So now the server that I'm gonna help you learn today is Adafruit IO. It's a server given by the board manufacturer named Adafruit, and they use a lot of sensors, boards, and everything in the IoT platform. And to make use of that, they have provided a free, limited usage, I would say, not free, a limited free usage server which you can use for projects when you are working in the beginning. And how this IoT works, sending the data to the cloud or subscribing the data from the cloud is using a protocol called MQTT. So MQTT is the protocol behind Facebook chat, Instagram chat, and everything. It's basically needs only a lower bandwidth to function. It doesn't need a huge bandwidth to work on because the data that we send are very limited. So it uses that. And two major steps that involved in MQTT are publish and subscribe. So publish is the process of client sending something to the server. That is, let's say you upload something to YouTube. That is publishing. You publish the data, right? Subscribe is something the other way around. So you subscribe to a specific channel. So you get things or resources from the server is called a client getting the things from the server is called subscription. So that is subscribe. So basically it involves two steps. So the first thing that we are going to see is the process of sending things from your device to the server. And it involves very simple three steps. They are, first one, this client. So now in the first case in local networking, this was used as a server creating an access point, right? Now in this case, we are going to make this as a client. So the first step is, how do I connect this board, this client to the internet? That is the first step. Second step is, how do I connect this client to the server, which is the server we are using today is Adafruit IO. So how do I connect this client to the Adafruit IO server? And the third and the last step is, how do I publish the sensor data to the cloud? So if you know these three simple steps, trust me, you can publish any sensor data and you can monitor the water level at your home, the LPG level at your home, the temperature at your home, or anything from anywhere you can monitor literally if you learn these steps. So the first step, connect client to the internet. So again, same process, no need of memorizing anything. Libraries, so simple functions, you can do it things with ease. So how do you connect the client to the internet is, we are going to use a library called ESP8266 Wi-Fi.h. So what is the name of the library? ESP8266 Wi-Fi.h is the name of the library, right? And how do you connect the client to the internet is, first you have to create an object called Wi-Fi client. You can name anything. So in our case, I'm going to name this client as ESP, and the object class is Wi-Fi client. Got it? So you are creating a object. This object as client, you have given a name, and the class is Wi-Fi client. And how do you connect to the internet is very simple. It's a so predefined class. So how do you connect is, you have to give the name, that is username and password of the network to which you want to get connected to. So how do you do it is, so define the username where you want to get connected to, define the password, simple, Wi-Fi.begin, within bracket, you have to give the name of the Wi-Fi and the password. Like how you did server.begin, you did username password, right? Same thing here. Wi-Fi.begin will make this particular client to get connected to the network that you are describing here. So it can be the name of the hotspot that you want to get connected to, or the name of the Wi-Fi router that you have at home. So whatever it is, you have to give it here. And then serial.println Wi-Fi.local IP, that will get the IP address of the router to which you are getting connected to. For example, in my case, it will give you the IP address of my home's router. Got it? So first step is connecting the client to the internet. The step is very simple. Wi-Fi.begin within bracket Wi-Fi, that is the username, comma password. Now next, connecting client to the internet. So it's very explained elaborately here. The same process is what I told you earlier. So the library name, the name of the Wi-Fi, password, and creating a client, and then connecting it to the internet step. Got it? Next step, connect the client to the server. So the client is this ESP, server is Adafruit IO, right? So how do you do it? So Adafruit MQTT client.h is the library that is required when you want to work with the Adafruit server, right? So now using this library, if you want to get connected to the server, all you have to do is MQTT, that is a protocol name, and this is a library, and Amazon ESP is the name of the client who is going to get connected to it, and then name of the client, as I said. Server is the name of the server. So the name of the server is io.adafruit.com, and then port, it's common, 1883 is the common port name. Username is like how in MIT App Inventor you created an account, in Adafruit IO also you have to create an account. So once you create an account, you can give your username and password. So basically that is the username here. Key is Adafruit IO key. This is there. And I'll show you practically when I'm showing the Adafruit IO dashboard. You can see that time. So remember this Adafruit MQTT client, you are going to give the name of the client, name of the server, port number, and the Adafruit username and the password key. Got it? So now how to connect to the client is, as you know, server name is io.adafruit.com, port number is 1883, username, your username you can give, your key you can give when you want to get connected to the server. And after describing all this thing, if you just write mqtt.connect, the client will get connected to the server. mqtt.connect, that will connect the client to the server. And mqtt.connected is a function or a command that is used to check if the connection is established between this client and that server. So that is very handful when you are not sure if the client is connected to the server correctly or not. Got it? So now this steps. First step, giving all the name of the server, port, everything. You have to define everything. Server name, port number, username, and the password key. And in setup, all you have to do is mqtt.connect. This is basically checking if it is connected or not, and if it's connected, it goes to the loop function. Simple. So basically, you are connecting to the server. The third step is publish. Publish is very simple. Adafruit MQTT underscore publish. Feed. Feed is the place where you are going to publish your value. So same process. MQTT username in feeds where you want to publish. So giving the location. So here is an example. So I'll show you practically because this will be a lot confusing. So I'll show you practically what is io.adafruit. So let's go to io.adafruit.com. So here it is. So basically, since I already have an account, it's like this. But if you don't have an account, so simply it will be like this. So here, all you have to do is go get started for free, create an account for yourself, you're done. And you can give your username, password will be generated. You can give a password for signing in. So this password, so I already have signed it through one of my trainers profile. So I'm signing in. So we were talking about feeds, right? So this is feeds. You can create your own feed actually. So how to create your own feed is, so view all. So here if you see, you can create a new feed. It can be already I have a Sairam, so I'll go with CSE now for the demo purpose. So I have created a feed in the name of CSE. Same thing you have to do in the Arduino program when you're doing, like for example, when you give here, so instead of photo cell, you'll have to give whatever the feed name you're going to use. Got it? Right? So now coming back to feeds, it is here. And apart from that, the interesting thing about this particular Adafruit IO platform is you can create a dashboard. Dashboard is basically how you want to see the data, right? So you can see in a gauge format, or if you want to add, you can add also a lot of like create a new block. No, you have these many interfaces. You can watch live stream. You can watch like in a graph format, line chart format, and if you want to control things, you can use number pad, buttons, slider, everything you can use. So let's keep it simple. I have gauge format now. So what I'm going to do is I'm going to write a simple program, the same whatever I taught you. So here it is. Same process. First step, the library name. So this is the two libraries that we are using today, mqtt.client.h and esp8266 wi-fi.h. First step is connecting the client to the internet. So this is the router name and password at my home. And how do you connect it is, so where it is connecting here, wi-fi.begin, the name of the user, that is Wi-Fi name and password. Second step is connecting the client to the server. So here it is. So the server name, the port number, the username, and the AIO key of the Adafruit account. And you create a client, and then to make it connect to the client, this is the line. You know how it works. And then next step is publishing. So publishing is I'm publishing it to the feed name LDR, right? So what I'm doing in the setup function is I'm going to connect a LDR sensor. So I have a LDR sensor here. So I'm going to connect this to the node MCU and send that analog value to the Adafruit server. So let me give the connection. So blue color wire is A0, so it goes here, and black is for ground. So I have connected the LDR sensor to A0, that is why it is here A0. And similarly, how you made a pin high or low, similarly to read a value from that particular pin, to read analog value, it's analog, read the pin number A0. So it gives you the analog value. So whatever I'm getting it, I'm publishing it. So I'm publishing it to the server. So this is a simple program that would help you sensor data from this node MCU to the io.adafruit server. So let it get compiled and uploaded. So it is getting compiled. And all these steps are simply to identify if all the connections are happening properly. So don't consider it as a big deal. I'll show you why those things are there after the programming is done. So you just remember the 4 steps I told you. Connect the client to the internet, connect the client to the server, and then publish. And then in the next part, subscribe. That's it. So upload it. So now if I open here, the serial monitor, it's already open. There is a serial monitor. See here. So those lines are basically to make sure that if the Wi-Fi is connected, if it is connected, only then it will go to the success line. Else it will be dot, 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 right? So now go to the server. You see the value here. So it's 1024, the maximum value. Now when the light intensity falls, so whatever sensor value, so it changes. Got it? So more the light, less the value, and the light intensity reduces, the value keeps increasing till 1024. Understood? So not just as a gauge, you can also watch it like a feed here, and you can see the same in the feeds also. So if you want to go here, so in feeds also, the same data keeps coming here. So you see here with the date and time. Clear? So this is how you can interface a sensor and send that sensor data to cloud, which you can monitor from anywhere in the world, not just sitting at my home and monitoring this. If I have Justman's Justman's account, I can literally monitor the value from anywhere. So now when you have a LDR sensor, it becomes a light monitoring system, correct? When you put a temperature sensor there, it literally becomes a temperature monitoring unit. You can literally monitor the temperature of a place from anywhere. You can even monitor the LPG level, the water level in your overhead water tank, or let's say the floodgates, even the flood value. No, the government, if they want to have a centralized dam level measurement system, they can IoTify that and monitor the level of dams and every all the dams at a single place. That is also possible. So this is how IoT is helping us by allowing us to send sensor data to cloud, and you can monitor anything from anywhere in the world. So that is io.adafruit publish. So publish, is it clear? So how you can publish a sensor data to cloud? Maybe it's a very short time, may not be the programming part is very clear to you, but trust me, you can Google and find a similar program, and you will understand why this particular piece of code is written. So it is the part that makes the client connected to the internet. It is the part that makes the client connected to the server, and this is the part that publishes the sensor data to the cloud, and this is the part that reads the sensor value. You will be able to understand maybe in a better way after this session. Clear? Any questions? If you have any questions, you can maybe ask your queries for a minute if you wish, or we will proceed to the next one. So next step
The
that we are
Adafruit is also open source, sir, or is it licensed also?
the Adafruit, right?
Yes, sir.
The Adafruit, I'll show you here. See here. Okay, here we will see.
Yeah, normally they give a free account only for 1 month or so. Is it like that or?
No, it's a free account, but the amount of data that you submit, right, that
Yes,
has
sir.
a limitation. So the
Okay.
limitation is it's 20 data per minute or something. So
So for project purposes, we'll be able to use it.
yes, it has limitation for free account, but you can pay and use. But for limited account only, I'm doing all this stuff. So
Okay.
with
Okay.
problem here.
Thank you.
And if
Sir,
you
this is Sendruma from IIT College. Uh, Sir, this is Sendruma from IIT College. Will you please send me the link, sir, for that, sir?
io.adafruit.com.
Is it possible to post it in chat box, sir?
I'll definitely put it there.
Is it possible? Okay, sir.
Okay, it's there. The server thing is there. Also, MIT App Inventor. Also, I'll put it for you guys. Uh, so MIT App Inventor is also there. So you can make use of both. And if someone wants to use other servers, you can check out Firebase from Google. So that has no limitation, and it is also very simple. But the only problem is you'll not be able to see in a very interactive way like how you were able to see here in Adafruit. So it will be like more of only database, like tables. You will be able to see the data. So Firebase also you can go and check it out later. But here in Adafruit, you have this kind of dashboard appearance that it's more appealing for users when they see it, right? Okay. All right. So now the next step is subscribe. Before moving to subscribe, I have to pick up a demo bulb. I need a bulb. Okay, I'm sorry for making you guys wait. So it's here. I've set it up.
सर ऑडियो नहीं आ रहा आपका.
Can you hear me now?
Yes, sir.
Yes, sir. Yes, sir. It's clear, sir. Yes, sir. You can go ahead, sir.
Sure. Let's move to the publishing part. Publishing part is done. Let's move to the subscribing now. So subscribing is basically the process of client getting a data from the server, like Adafruit or something. So using subscribe concept, what we are going to do today is you have Google Voice Assistant in your phone, right? So using the Google Voice Assistant, when you talk something, you can literally control things on the other side in the world. That is what is the plan today. So now same, like how publish, subscribe also has the same steps. You have to make your client get connected to the internet, client to the server, and then subscribe data from the server. So the first two steps are the same. So I'm not going to focus much on that. The third step is subscribe, same line. Like how Adafruit underscore MQTT underscore publish, you publish to a particular feed. Similarly here, instead of publish, it's subscribe and the feed name. Same process, username, feeds, and where you want to subscribe from. As simple as this, right? So now, same thing. So it should be very clear for you. So how to read that value is mqtt.subscribe ampersand from that feed. That particular feed, if you give, so it will be reading from that particular feed. So now, how do I make that particular concept that I was telling you is, you are going to use Google Voice Assistant on one side, and on the other side, you are going to get data from the Adafruit IO server. So this IFTTT is a platform which is very simple. If this, then that. So it is used to connect apps together. Like you can connect your Adafruit with Facebook, your Gmail with Facebook, your Adafruit with Gmail. So whatever you want to do now, you can literally connect. It is available in Play Store. It is available in iOS Store as well. So you can just download the app and then see how you can play with it later. So it's IFTTT. So now what happens is when I talk to my Google Voice Assistant, let's say I say turn on the bulb. So that particular phrase in IFTTT, what it happens in the background is it submits a value to the Adafruit server. So instead of, in this case, we submitted through LDR sensor, right? So in this case, instead of a sensor submitting a value, so whatever you talk in your phone, no, so your IFTTT will take that phrase and submits the value in the Adafruit server. So this is what is happening. So it sends this data to the server. And when that particular value is that, what happens with on the node MCU is, so it takes the value from, subtracts the value from the Adafruit server, and then in turn controls the program on the, controls the LED or the bulb on the node MCU. So this is the whole thing happening. So now let me show how this works. I'll have to show you the code, home automation. So here is the code, very simple, same library, two libraries. And this is the name of the Wi-Fi and password at home. And the step to make it get connected to the internet is here, Wi-Fi.begin Wi-Fi comma password. And next step is connecting the client to the server. So details are here. Steps to connect is here. And then subscribe. So subscribe is this line of code, right? From the home auto feed, it subscribes the value, and I have connected a LED or a bulb. So that will be based on the value submitted. It's going to be turned on or turned off respectively. Now let me show you the demo. So the wire, I don't have a lengthy wire. So I have to power up that different node MC that I have as a board. I'll remove that and show you to you later after the demo. So now it is connected. This bulb is connected to the node MCU using a relay. So now I'm going to open the voice assistant in my phone. Okay, if you want to see, I'll better connect it also. So it's here. Let's open up the Google Voice Assistant. Turn on the bulb.
Turning on.
So now, okay, there is a small delay, but you can see the bulb turned on, right? Similarly, bulb off.
Turning off.
So you can literally turn on and turn off the bulb. I have used only two commands. And if you want to see what happens behind, like in Adafruit, I'll show you here. So the feed I told you was home auto, right? So the IFTTT app in my phone, what it does is whenever I say bulb on,
Turning on.
see, it submitted a value 0, right? So when I say bulb off,
Turning off.
it submits a value 1. So for one device, if you have two commands 0 and 1, you can make use of it. When you have multiple devices, someone was asking in the beginning, I want to control everything, right? So you add multiple relays. I'll actually show you. I'm not sure if I will be able to pull it from here. Let me get up and pull that and show it to you. So here is a simple hardware, a node MCU board with a simple 5 volts relay, and then you give a connection. You can build a smart home or a Google Assistant voice controlled home at ease from your home. So this is with respect to the Google Voice Assistant. So you can literally control anything from anywhere in the world, right? So any questions? So not just bulbs, you can literally control motors, servos, displays, and then you can think of the application where you want to. So basically, if you have a knowledge of how to work with some different sensors and actuators with the knowledge on this particular node MCU, you can literally build any smart IoT projects that you wanted to help your students with, or the crazy ideas that you want to build and you apply in your homes, or do a simple innovative project and impress your kid. So anything you can do if you have this knowledge of working with node MCUs. Okay, so any questions from your end?
Sir, this is Senthilkumar from IIT College, sir.
Okay.
Sir, so if you want IoT using Arduino, you need Arduino board and node Wi-Fi, and then you have to install IFTT in your mobile phone, and you
Yes.
have to install Google Assistant in your mobile phone. And these 4 are enough.
Yes, this 4 is enough. You don't need an Arduino board actually. You need a node MCU board, and
Okay.
you need Arduino software in your computer, and then you
Okay.
have to install IFTTT in your phone and configure it. So if you want to know how IFTTT is configured, I'll have to show you. So here is IFTTT. So basically you have to create that applets. So here create is there, no? You can go and create your applet. So first, if this,
Okay.
in this, okay, now you have created 3 applets. Now to create unlimited applets, upgrade. So I think they have upgraded the system. So I cannot create a new one now because I already have enough. I'll open up one and show you. So this is one of the applet that I created. So if you go to the settings, you will see the phrase, whatever phrase you want to say, bulb off in Google Assistant, or turn off the bulb, or any other way you can add, and then what you want the assistant to reply to you. It said turning off, turning on, right? You can have funny codes also there, and then what feed in the Adafruit. So Adafruit is linked here. In Adafruit, to which feed you want to send the data. So these are the feeds that I have in Jashwin's account. You would have seen that in the Adafruit, right? Home auto, LDR, water levels, IRAM, CAC, everything. So in that home auto, and what data you want to send. It can be any number. It can be any number, any character, anything you want to, and then you have to save it. This is for LED off, that is bulb off. Similarly, I have for bulb on also. So it should be somewhere. Yeah,
How
here.
to link IoT with the Google Assistant, sir?
How to?
How to link IF? How to link IFTT with Google Assistant?
If you want that, then I have to delete one of these. Let me try deleting it. So this is a applet that we created for. Okay. So now if this, in this you have to add, in this you have to add Google Assistant, correct?
Okay, okay.
So you have to search for Google Assistant. It comes
Server.
here.
We have to select.
Yeah.
Yeah.
So add the server, and any phrase, like I'm going to say a simple phrase, right? So say a phrase. So what do you want to say? Earlier you saw bulb on, right? Let me keep it LED on or something. So LED on. It's very simple, straightforward. You want to say in another word or another phrase. turn on the LED. Whatever you want to say no, you have to give it here. And assistant response. This is basically the response that you will be getting from the assistant. It can be okay, done, or whatever it you want. Language should be English. Okay. And so now this part is configured. Now that part is Adafruit. So here you go, search for Adafruit. So Adafruit is here. And here send data to Adafruit. So since I have already added my Adafruit account here, it shows here. So whatever feed you want to know, you can select that, and the data that you want to send also you can give, and then give continue. That's it. As simple as that. So you have to review. And then if you say LED on, so send data to CSC feed is 0, that will go there, and you can finish your applet. So now IFTP allows you to only to create 3 applets. Remember that 3 applets for free.
So the SATA tool only is going to link IFTP with node server.
No. IFTP is linked, like is connecting the Google Assistant and the Adafruit. So the node MC, what it does is it actually goes and checks the value in the Adafruit server.
Okay. So we have to feed the ADA tool details like link something like that. Contain link something like that.
I didn't understand your question. Like,
sir, so we have to feed the node server, our node server details in the ADA tool.
I showed you in this program, right? This is a program that goes and checks the Adafruit server value. So here,
okay, okay,
goes and checks in the home auto, and in the home auto, if the value is equal to 1, it does one thing, and if the value is 0, it does the other thing.
Okay.
Like,
so the activation key used to link ADA tool with it.
Okay, you need the activation key, so you can see it here.
The activation key itself, where we can get that activation key by connecting node server to our mail ID or WhatsApp.
No. If you want to connect your Adafruit, Node MC to Adafruit, you need these 4 information. Here, right? So you know the server name io.adafruit.com is very straightforward. 1883 is also straightforward. These 2 only you should know. So your username and your key. So that is available here. So if you go to your Adafruit account, you go to my key, you will see the username and the key. You just copy this and have it in your Arduino like Node MC code. Your work will be done. Understood?
Okay. Sir, I have one small doubt.
Okay.
Actually, you have said about the interfacing of Google Assistant with Adafruit, and also we have understood the other case. Previously, we have written the same program without IFTTT, right, sir, in Node MCU. Now we have done with IFTTT. Is there any difference in the coding?
There is no difference in the coding. See, in the first case, what you did was publish.
Yes.
Publish is basically sending sensor data from this board to the server.
Yeah. Yes.
Now, in the second case,
we are doing the subscribing.
Let's say another board, like we have 2 boards. So this board is publishing the data and this board is subscribing the data. To be exact, this board is subscribing board.
Okay.
So instead of submitting a value from a board or a sensor, we wanted Google Assistant as the input, correct?
Okay. Yes.
So in order to connect the Google Assistant and the Adafruit, we need the bridge. That bridge is IFTTT.
Okay.
In IFTTT,
what defaulting, sir? Is that the defaulting?
Yes, by default you need someone to bridge, right?
Yeah. Okay.
So IFTTT acts as a bridge between your Google Voice Assistant getting the phrase and in turn submitting a value to Adafruit.
So whenever you want to subscribe data, this has to be configured.
IFTTT has to be done. Suppose if you don't want to use Google Voice Assistant, you want something to happen automatically. You submit a value through a sensor to the cloud.
Okay. So from that feed, we will be able to get it.
Yes, subscribe and do whatever you want.
Okay. And is this is there any restriction on the database which we can use with Node MCU, sir, or any database will be able to use like cloud server?
It's going to be here. The database is going to be on the server, like Adafruit or Google Firebase or AWS somewhere. So it depends on the server side. It's not. It doesn't based on the Node MCU side.
Oh, okay. Thank you, sir.
Okay. So now, if you have further interest to learn and work with all these related concepts. So we at Lema Labs, to give you an idea of who we are a team of very young and enthusiastic engineers who are trying to empower this generation with powerful technologies like robotics, IoT, machine learning, and so on. So our team was started back in 2010 when our founders were doing second year of engineering at IIT Madras under the guidance of faculty members like L.S. Ganeshan sir, T.S. Natarajan sir. So we work as a team to teach technology to anyone who is interested. So they need not have any proper background or having a proper skill set on a particular technology. So all can be beginners, but we make sure through the course, we start from ground zero and then we eventually take them learning technology and help them get the confidence that they can work on any project that they are interested in that particular technology. And with respect to Internet of Things, we have been doing it through our IoT workshop, which we have been conducting in IIT Madras Research Park and even colleges like Sairam Engineering College, Government College of Technology, or a couple of colleges in Bangalore like GC, like Global Academy of Technology, and a college in Mysore, VVC. So many places we have been offering this course. So this particular workshop is a 2 days activity where you get to work with this particular node MCU from the very basic, and you get a takeaway kit, and then you work on whatever concept I have covered in this session as a demo. You get to work with it completely hands-on. So maybe if you are a faculty who is interested to learn IoT, you can definitely try it out. Or you can recommend your students to try out. Trust me, after the course, they will have this complete knowledge of working with Node MCU, creating HTML program, and then how to work with the Arduino programming, and then create like control devices in local network, and then create application using MIT App Inventor platform, and then how to send sensor data to the cloud and substrate sensor data from the cloud and build these kind of smart home related project, smart dustbin related project, anything they can be building in just 2 days of training at Lema Labs. So whom this program is for is anyone who is interested in learning IoT, anyone who want to be a part of a community of like-minded people who want to build, and then solve real-world problem, you can definitely give it a try. And if you're someone who want to make your students build their own project, or if you yourself want to build some project and gain some hands-on experience, you can definitely try out the program. So this workshop, we actually have been doing it like 2 days of workshop and then followed by 1 day of project building at colleges, so that students learn the technology, and then end of the session, they are confident to solve a problem after the course. So we are highly feedback oriented people, and this is something that we have been getting from all the participants through the various programs. And 81% of them said they had a lot of fun because we teach things in a very simple way, and our trainers are very friendly and approachable. So you'll have a lot of fun and learning. And 99% of them have reported that they have learned all the concept in a very better understanding manner. So that is something. And these are the colleges where we have been conducting our programs in the past, starting from SRM, Sairam, Rajalakshmi Engineering College, JPR, Crescent, almost all colleges in Chennai, and a couple of colleges in Bangalore like Kumaraguru, and then GCT, and then Sri Krishna, and also Amrita students are trying our program. And even in Bangalore, like Global Academy of Technology and VVC colleges like this. For rest of the colleges, they directly come to our IIT Research Park and attend our program. And this is from Sairam. We do our program. This is from Global Academy of Technology. This is VVCE. This is Global Academy of Technology, where students, along with at least couple of faculties, will attend the program. So that is what has happened in the past. So now After the course, it's certified program, so you get a certificate from Lema Labs and IIT Madras Alumni Association. And the fee that we have been charging for the workshop was around 3,000 rupees. So it's inclusive of 2 days of training, takeaway kit, and the guidance that you get when you're working on a project, and the venue cost at IIT Madras Research Park. And if it is happening in the campuses like Sairam, we have been charging it at a very lesser price, removing the venue charges, around 2,500 rupees. We have been doing it. So now everything is different, right? Even no more classes are happening in the classes in your colleges. So how do I attend? How can our student learn such thing is the biggest question that you have, right? Yes, even we have adapted to this pandemic situation, and anyone can learn all these concepts from anywhere, anytime, by creating a virtual e-learning portal. We have a e-learning portal. So anytime in the sense, it's like Coursera or Udemy. We have our own learning management system. You can sign up for the program. It's completely hands-on. You will be placing an order to get the kit. You get your kit delivered to your home within a week or 10 days of time. You can work on the project. You can get complete guidance from Lema Labs for the during the course and after the course as well. And the fee for the program is 1499 for the training access and 849 for the kit. You get a Node MCU board, a relay module, a sensor, USB cable, everything will be there in the kit. And how you can register for the program is you can just go to our website lemalabs.com, go to the IoT workshop page, and you can definitely find the link for the e-learning course. And anyone who attends the course, you can get a special discount of 200 rupees valid from today for 10 days. To get the discount, you can reach out to me. I'll give you my contact details. You can reach out to me if you're interested, and then you can avail that discount of 200 rupees after the session. So how to reach out to Parthiban is you can reach out to me on this number, or you can reach out to me on LinkedIn. So LinkedIn profile is here, or you can WhatsApp me or mail me as well. So I'll put all the links in the chat column. You can just take it from there. So I'll start with my name, and mail ID is parthiban at lemalab.com. Meanwhile, if anyone has a doubt, you can feel free to ask now.
Sir,
And
I am
then,
having a doubt. So, those who are going to get the e-learning, so are they going to
yes,
get your PPT or some the study material also along with the lectures?
yes, you get a video lecture available. You can access anytime. I'll show you the portal if you're interested to see now. And you get all the study materials. You get connected to the trainer in a WhatsApp group. They will guide you on the process whenever you have any doubt. All those things happens there.
Okay, sir. Okay. Thank you, sir.
I'll show you the portal, and if anyone wants to WhatsApp me, here is a WhatsApp link. And if anyone wants to follow me on LinkedIn to reach out professionally, getting some help regarding training activities in your college, or any doubts on the projects that you are working on, you can reach out to me. Okay, my LinkedIn is also there. You can definitely reach out to me there. Also, I'll share a quick feedback link because, as I said, we are very feedback oriented people. So your feedback would definitely help me get better at delivering the next session. So I'm putting the feedback link here. So this is for Lema Labs purpose. So feel free to give your valuable feedback there.
Participants, first you need to fill the feedback shared by our resource person, Mr. Parthiban. First you complete it, and then we will put the attendance link. First you complete the feedback link posted by Parthiban sir, and then we'll post the attendance link. Thank you, participants.
Welcome. Okay, so someone asked for the learning. Lema Labs also offers course on machine learning. So if anyone interested in learning also can go and check out the machine learning courses. So here is
Do the
the
Lema Lab also provide the courses on Python and VLSI?
Python is covered in the machine learning course, but VLSI we don't have now.
Okay. The
Now
Python is covered in, pardon?
machine learning course, the 13 week machine learning course that we offer.
Okay, okay.
And this is how the platform is. So you get to watch the video lectures.
In this video, we will see what is IoT and how is IoT going to create an impact in our lives. Internet as we know it now, what does it do? It helps people around the world communicate with each other.
So basically, you get all video lectures available. I have forwarded it because I don't have time to show everything for you now.
Lives easier. Not only is it going to make all our lives easier, it's also going to help businesses collect data so that they can anticipate the needs of their customers.
Like this. And after every particular concept, right, you'll have to answer questions and then proceed to the next part. So that is how it is done. So what makes a device smart? Today we covered this. Can anyone answer? What makes a device smart? Devices that has network capability
Network connectivity.
and collecting and sharing information. So answer is both A and B, something like this. So this is how the entire lecture is planned. So you like it is divided into two parts: IoT over local network. And since I haven't started, so this is my profile. I haven't started learning now. So I'm logged to access this one. So maybe if you're doing, you will be able to see. So all concepts will be explained to you with live examples, simple examples, so that you can understand the concept. I mean,
In this video, we will learn a few C programming basics. Most of you are already familiar with this, but let's just do a small recap. Okay, so let's start with conditional statement.
so this is how all the concepts are taught. So even the screen sharing part also will be there, where you work, how you work with Arduino, how you work with components, that also will be there. Let me try it. So this is what, so I have covered you today, but I did it as a demo. But if you take up this course, you will be able to do it practically with hardware in your place.
Now, before we see how to make an LED work, we need to understand another important concept.
Sir, so this is the video lecture. So if we have any problem,
Yes.
do we have the online trainer is available that time also? Means this is the video lecture. So
Yes,
if I am having a doubt or if I am having a problem that time.
Okay, we help in two ways. So you have a chat option available here. You can directly start chatting with the trainer. Also, anytime a user signs up for the program, we add them to a WhatsApp group, where in the WhatsApp group, the trainers will be there all the time. You can get doubts clarified from them directly.
Okay, sir. Okay, thank you, sir.
Welcome. And I'll put this link also in the chat so that if anyone wants to go and see, right, you can definitely. It's learn.lemalabs.com. You can go there and sign up and then order your kit. it will be delivered within 10 days of time maximum. And post that you can start learning all this concepts I covered as a demo today. You or if you're interested in letting your students learn also, you can do that, because I feel it will be more suitable for students and faculties. If you are really interested and you want to learn all this stuff to guide your students, you can also definitely take this on.
Parthiban sir, you have done, right?
Yes, done, sir. I'm over.
Okay, dear participants, it's time to felicitate our chief guest of the morning today, Mr. Parthiban. ATAL coordinator Dr. Meena Kabilan will say a few words regarding. Thank you, madam.
Parthiban sir.
Yes, ma'am.
Very good afternoon, sir.
Good afternoon.
Thank you, sir. Thank you so much for your valuable time you have to spend with us. For the past 3 days, participants attended only the theory session. I hope now they got some practical knowledge. And we are happy to share with all the participants. We have MOU with this great organization. Thank you, sir. Thank you so much. We are expecting your continuous support with our organization and our team. Sir, thank you.
Pleasure, ma'am. Always there to share knowledge. So I'm really happy that all the participants who are faculties in various organizations felt the session to be very informative, excellent. I'm really thankful to all of them for like almost 144 participants are still there in the meeting. So it means they all enjoyed it. So I'm really thankful for the opportunity from Sairam once again. And I'm ready to continue giving this support to Sairam, not just Sairam, for all the colleges who are interested in empowering students or faculty with tech. So I'm there always. Thank you.
Thank you, sir. Here only 20% of participants from Tamil Nadu, all others from throughout India. Almost we cover all the states from India, sir.
Okay.
Thank you, sir. Thank you so much.
Pleasure. Thank you.
Thank you, sir. Thank you once again, sir. Thank you.